traditional systems. So a little refresh your memory on operating system and so on is this is the set of all the components that provide the operational foundation for software. So you are not, when you write the software, you just focus on the task at your hand, right? It's a very high level interface where you, let's say you want to send an email, you want to send a message, or you want to do some computations, right? So you are not, in order for you to be more productive, there is a software which sits in between the machine, the actual machine, and your interface, and which do a lot of things so that you can use the machine nicely. Okay? And we'll see the details about it. The software is, if you want to define software, is the set of all the programs and applications that execute their instructions on the hardware. Right? So whatever you write and that gets executed is the software. And this OS is the glue between hardware and software. So what is a kernel? Can anybody tell me what is a kernel of an operating system? OS and hardware. So let's if we assume OS to be the glue between hardware and software. So OS is the glue, right? So
heart of the operating system.
Heart of the operating system, or so I mean, in technical terms, what you can say? The core, right? So what core means is without it there is no point in having an operating system. Now what it means to have, what is the first thing that operating system needs to do? Process, right? Anything you want to do is execute on the computer, right? There is nothing other than execution. Anything is the first thing is to execute, and if you want to execute, the first thing is to have processes. You start a process, and that process will run, and then it will become part of the kernel. So the job of the kernel is to take a program and make it a process. What is the difference between program and a process?
Programming running state is a process.
Right. So program is the static state where you compile all the instructions, you have these instructions just sitting. And when you put it into the life, when it starts running, it becomes a process. Right? So OS, whole job, but the kernel, what it does is it creates processes and manages processes. And similarly, this is one resource. So CPU is a resource. What is the other resource? Memory. Right, so memory is another resource. Again, there is different types of memory in the system. There is one which is called registers inside the processor, which is very fast to execute or to access. Then there is RAM, and then there is hard disk, and so on. Right? Then there is flash, there is USB, there is DVD, CD, and so on. So all of these are memories. It's a resource. So operating system even has to manage this resource, and that also will become part of the kernel. So these are the core things that operating system does. If we look at a real example of a phone and see what operating system will do for that. So let's say you are getting an SMS message. So what happens is, on the left you see the hardware, on the right hand side it's your software that you are writing, it's the application program. In between is the OS, operating system. Okay. So what happens is, when somebody sends you an SMS, the cell phone tower will try to connect to your phone, and we'll see the details about how this connection happens. But, so this is what, the radio gets excited. So radio is continuously looking for messages on one channel. So every phone will, let's assume that every phone has its own channel, and channel as in frequency, it's reading that frequency continuously, the radio is turned on. When it sees some energy on that radio channel, so for example if the frequency is 2.4 gigahertz, it will see that there is a lot of energy in it. So it knows that there is some kind of message coming in. So radio will try to get these messages. The messages will come bit by bit. Right? So all of these messages are coming into the hardware. Here. So hardware right now is getting all these bits by bits from the airwave, and when it sees something which is a cohesive unit, right? So it sees the start bit, it sees the end bit, and it also sees something called CRC. To make sure that all these bits are correct, there is no error in it. When it sees this, it notifies the operating system that I am receiving the message on the radio and you need to take care of this message. So the operating system gets notified. So all of these things are called events typically. Okay. So hardware also internally gets an interrupt. Operating system will get an interrupt, and then operating system will engage with the hardware. So what is done is just one packet is not the whole message. The message itself will consist of multiple packets. So packet by packet, it will tell the hardware that I am interested in this message, and you start giving me this message in this memory location. Okay? So there is some memory location inside the operating system, and then hardware will start putting the message there, and will keep notifying. Okay, first packet, second packet, third packet, and so on. So this is what the communication happens here. Okay? So when operating system gets the whole message, it will do the same even software. That there is such and such message. So if you are deciding on a port number 9000, right, and there is an application running which is interested in port number 9000, that application will be notified that there is SMS message or Symbian message, whatever, on port number 9000, and it could be in a different format. So right now here it was totally a memory access. This could be a file access. And so this is what defines the operating system, how it is communicating with the other side, with the software. Anybody knows what could be the other interface? So one I said was the file interface. An example of the file interface, do you know of any operating system which in principle does everything as a file? Linux or Unix. So everything is a file there. Even a network connection is a file. If you open up a network connection to a server, even that is a file, right? So this is one example. Another example could be, it's not a file, it's an object. So you have done the object-oriented programming. You know what an object is. So you can create an object. The object will encapsulate the data part and also some functions. For example, for the SMS, it could be the text of the SMS, and the functions could be, so get me from address, right? Get me to address, and so on. So it will come everything as a bundle, and then give this to an object to the software, right? And we'll see in Symbian what is the standard way of communication. But as an even example, in Windows it could be an object, in Linux or Unix it could be all files, and so on. Right. So this is what the notification, it will access the message, it gets the message, and now this message is not in the control of operating system. So one thing to notice here is, hardware is not aware of the operating system. It just sends a notification, and it doesn't know who is receiving this notification. It doesn't know that there is an operating system. Similarly, software is not aware of the operating system. It will just say, okay, give me some notification, right? And this is and the use of this principle is because then we can change the operating system in between. We can go from one operating system to another operating system, and this hardware and software still will stay the same. That is the reason both of them are not aware of the operating system. So this is one example of the SMS that I given you and showed you how exactly everything is orchestrated. So you already have seen this, what's happening is, so the hardware receives radio signals, so it's all in radio frequency and energy. It notifies OS that some data is arriving. If OS is interested in receiving this data, OS could even say that I am not interested in receiving any messages for now. And then the hardware will just ignore all those data. Right? But if OS is interested, it will engage with the source by receiving all these messages using appropriate data protocol. Right? So data protocol is in, so TCP/IP is a protocol, GSM is a protocol, CDMA is a protocol. Right? So OS is aware of all these protocols, and it will follow the protocol and get the message. So when the message arrives, it stores the message and notifies the message manager inside the operating system. In this case it's a real application. So application uses the OS to access the stored message. It could be a file access, it could be an object access. Neither the hardware nor the software sees the OS, and that is how the code. So good OS as much as possible should be transparent for everybody. If that happens, then it's a really good OS. So how do we access OS? How is the application programming talking to OS? You know examples. Ability of code that actually connect to OS and communicates with the real OS in OS system, OS course. System call. And so you all know what system call is. So maybe you can tell me whether you have heard these terms. Have you used these terms? System call, Win32 APIs, POSIX APIs. So can you tell me? So let's start with the base Win32 API. What is Win32 API? What does it do?
Access various registry, a lot of things in Windows like registries in Windows and to manipulate things.
Right. So that is partly almost correct. So when you want to talk to Windows, but so there you will use the APIs, but there is more to this than just talking to Windows. Have you used the fork command? Creating a process. So fork is a command that you will use to create a new process. And that is the basic command of an operating system, right? As I said, process creation is the first thing OS do, and then in that the first command that OS will use is fork. So in fact in Unix, your whole machine is built on this command.
That is for Linux and Unix. Like in Win32 it will be create process.
Right. So this command is particularly you will use in POSIX. Okay. So POSIX means everything which ends with Linux, Unix, right? So that's why it's called POSIX.
So Linux is also based on Unix only, so it makes Linux is based on Unix also.
So there are some minor differences, and almost everything is the same, but there are some minor differences. And primarily it comes from Unix is a paid version. So it's developed by a company and it's not a free software. Linux is open source and free, right? So that is the primary difference.
Even Unix is open source.
It's open source, but it's not free. You have to purchase hardware, and then only in hardware and software both. Then you can use the formal version of it. You can get it, but otherwise it's a paid version. So POSIX APIs is for these kind of operating system, and this is of course for Windows, but still there is something more. So by the way, these are IEEE standards. So when I say POSIX compliant code, that means just like in the standards, so USB is a standard, Wi-Fi is a standard. Everybody that implements 802.11b follows that standard. So this is an industry IEEE standard. Okay, so what is the difference between this and this? A system call and these APIs.
Something common specific to an operating system.
Right. So system call is something that is inside the operating system, and operating system doesn't want you, for some reasons, I can tell you the reasons later, to directly call or make function calls to system calls. Right? So your program should not have system calls embedded in it. So what they do is, they will give you these APIs. So these are the libraries. So if you want to develop a code which is for Windows 2000 or Windows NT or Windows XP, you would use this code and then write that code instead of using system calls. Okay. Now the advantage is, if Microsoft changes its operating system, so tomorrow there is Windows 2012. So what will happen is the system call inside this new OS will be different, but the library interface will still be the same, Win32 APIs. So your code is compliant for a new version of Windows also. If you use the direct system calls within the operating system, you change the OS, everything will break, right? So that's the reason. So again in C, when you write C code and use POSIX system calls, it will run on Linux, it will run on Unix, and it will run on the latest version of Linux also, and it will not break. But if you use the system calls, change the operating system, your code will not break.
System calls are different for Fedora and Ubuntu.
It could be, they could be. There is no requirement that they should be same. So every operating system will have its own set of system calls. Okay, so is this part clear now? System calls, fork is one system call. Win32 and POSIX API is something which is on top of system call. So if you want to look at this, at the operating system, it's like this. System calls. And then there is this POSIX or Win30, right? And now there is Windows 64-bit machine also. So this is how you can access OS. So operating system is at the bottom, running on top of hardware, and then you have all these systems also sitting here, right? And these are the APIs I talked about, POSIX and Win32 APIs. So these are the APIs, and you can talk through them, right? So this is the APIs, and you can talk through them. So we'll see a little history of what Symbian is and how it came about. So in 1980s, the big thing was to develop PDAs, personal digital assistants. So almost all the research and the technology was going into the direction of PDAs, and the difference between, so this is an example of a PDA device. So it's a little bigger than your phone. It has a big screen with a stylus, so you can write with this or with using the stylus. And then, so the difference is this is using a smaller processor than a computer, than your PC, and your memory, everything is small. And it has a battery built in, which is different from again the PC, which typically used to come with the power adapter. Right? So you need to package almost everything. So this you will use to send an email, to send a message, to look at images and so on. So you need an operating system because it's not a very simple device. But still the operating system can't be same as Windows or Linux or Unix because those are bigger. The first attempt was made at this by Apple company, and their device was called Newton. So they tried to popularize this device. That did not work there. Right? Because most of the time the power wasn't there. So by the turn of 21st century, this device actually changed into something which we typically nowadays say as a smartphone. Right? So they are combining the phone because nobody wanted to carry a phone and a PDA separately. So that those two devices got combined. And Symbian OS was designed to run on these kind of devices, the smarter devices. So how the Symbian OS itself came in. So in 1988, it began something with a name called SIBO, which standard for 16-bit organizer. So because the PDA is typically an organizer, you have all the calendars and so on. So PDA was an organizer, and it was a 16-bit machine, so they just named it SIBO. So it started with that. It was the first computer, almost like a laptop. It will do almost everything as a laptop would do. And it had great success because it has very good power management. So this was a device, so unlike Apple Newton device, this became popular because it has good power management, including light, so it can diminish its lights and enhance its light. It will easily interoperate with computers. So this is a very important thing. If you want to create a device, it should work with the existing infrastructure. And it could do that. It was based in C, plain C, and then on top of that has an object-oriented design. So operating system underneath is C, but then everything on top you can access as an object. And so it has an engine approach, and we'll see what exactly all this means. After that, it evolved into something called EPOC, EPOC. So Symbian went from that first level of programming to the second version, it's called EPOC, and now this was totally programmed in C++. So that's why if you see today's Symbian computer or Symbian smartphones, it's all C++. It's called Symbian C++. And they extended this engine approach into series of servers. So we'll see what servers are and how they communicate and so on. And this was the company, Scion. that started with Symbian, and later on other companies joined. So Nokia primarily, then Ericsson, Motorola, Panasonic, because these were all in the development of PDAs and smartphones. So they all joined this company and they decided to create a common operating system. Primarily because once you move from one maker to another maker, then everything should still work the same. So they decided to have a common operating system, and that was the Symbian OS. Okay? So it has its roots in 1988. It's a very old operating system, as in it started very old, and the same problems nowadays that are seen by Windows, by being very old and we have to carry that all legacy applications, those are creeping into the Symbian OS also. Because it has to support so many devices, it becomes very hard to write very advanced things. Right? So today it's called Symbian OS. It's a general venture between multiple companies. Sorry?
Can you change the more light and expanded engine approach on the
Right, so we'll see what this means. What is expanded engine approach and how it came into the server approach. So I talked about, so a little bit of diagram if you want you to know is, so we talked about file interface for operating system. Then there is object-oriented interface. You send objects. And there is a third one, which is called a server-based approach. So all the communication between the operating system and the application is through client-server model. You all know what client-server model is. HTTP is a very good example. So you run an HTTP server on the internet, and all the things that happen on the internet are either client-server or peer-to-peer. The communication is through messages. Symbian OS, the same thing is being used. All the communication, even within your phone, is through client-server. So it sends messages and receives messages. So the advantage of doing this is everything becomes separate. Right? So you don't need to share a file, or you don't need to share an object. You are independent. Server is independent, client is independent. And even if you move one server over the network to another phone, you can still communicate using the same interface. You just have to send a message. And so these are the advantages, and we'll see in detail how it is being used. So one is a trivia that Apple, when it started with the iPad, right? So Apple was continuously working on this device. So it started with Apple Newton, it failed, didn't pick up, and they were continuously working. And that time they learned that stylus is something they can't use because it's very cumbersome. You have to use the stylus, you carry the stylus everywhere, keep writing. So Steve Jobs decided the stylus is not a good example. So he was working on this, and then finally in 2000, near 2000, after 2000, they figured out a technology where you can actually use fingers. And the primary challenge before that, even on ATM you could use fingers, right? But there wasn't something called multi-touch. Right? So multi-touch means you can touch the screen with multiple fingers. So for example, if I put two fingers, it should detect that it's two different fingers. The technology before 2000, you could just detect one touch. After 2000, he got this hands on a technology from a company, a startup company, where he could use multi-touch. So he started developing again not a smartphone, but actually a tablet. Right? And the iPad was almost ready. And then it struck in that if you could make a device which is portable and can do everything that a computer can do, why not create a phone with it? So Apple actually came up with iPad first internally. It was almost ready to launch, and they decided let's not launch it. They stopped it. They put the phone, the GSM and everything into it. They made it a little smaller, and the first thing that they came up with is the iPhone. Right? So actually they developed iPad before iPhone, but the released iPhone captured all the market, and then iPad came. So this is a history of how the... Okay, so coming back to the OS of these devices, what you have is a very less memory. Right? So typically an Android phone if you buy, how much is the memory? How much is the memory? RAM. I'm asking about RAM, not the flash disk. 1 GB?
512 MB.
512, yeah, 1 GB is very high end, but typically you will see about 500, 250. So iPhone started with 256 MB, now it is 512 MB, right? And Android phones, if you could go, I mean, it could go to 1 GB and so on. very less memory, less storage space. Right? So you will have 8 GB, 16 GB and so on in that range. It's still not in very high, like 256 GB or 512 GB. So less storage space, slower processor. So what is the state of the art processor on a phone or a tablet? Now it's the same.
But 1.4 gigahertz calling necessary.
Quad.
Not quad, 1.4 gigahertz. Single core.
Single. So there are dual core processors.
Dual core.
But dual core are low clock.
So how much is it?
1 gigahertz.
1 gigahertz. So it's about 1 gigahertz. And as you see, if you have single core, it will need to be 1.4 and so on. But still, it's very less compared to computer. But it's going in that direction. So all of this means you can't use your standard operating system. The operating system you just cannot port to this device. You have to do something else. And that's why all the efforts in Symbian, Android and iOS. Right? Power is power. So this is a big constraint, power. So battery technology is not growing at the same rate as the processor or memory. So processors are becoming faster, memory is getting cheaper and smaller, but battery technology is not catching up that fast. So power is still an issue. So what is the single most power consuming operation in nowadays? Wi-Fi or so Wi-Fi used to be the one. Now there is a different operation. If you think of on the current smartphone, what is the most energy consuming? GPS is also one. Yes, GPS is one, but Wi-Fi was, but now there is another one. Background task now. User display, right? So displays are becoming so powerful with very AMOLED display and HD displays and so on that it's the most energy. Wi-Fi used to be one, but nowadays the display is consuming too much power. So anything that you would do as an operating system, the first thing they want to cut down is the usage of the display. The less display you use, the better it is. Of course, GPS is still an energy consuming, but we don't typically use GPS continuously. But display is something that we use continuously. Second thing is power loss must be handled gracefully. So that means your device should not switch off. So it's not like it's on for a minute, running everything fine, suddenly next minute everything is turned off. Right? It should not die like this. So gracefully means first of all you should know when your battery is going to end. You should detect that. How much is the voltage, how much is the current you are consuming, and then tell the user well in advance the battery is going to die in these many minutes, and if it is going to die, close the applications which are unnecessary and could save you energy. For example, if the GPS is on, you can tell users switch off GPS, switch off Wi-Fi and so on, so that you get the last bit of energy to make phone calls. Because phone call is very important and you should save everything as much as possible to do the phone calls. So that is what it means, power loss must be handled gracefully. Right? So the curve should be going down slowly. It must support the multi-programming. It can't be a single programming because you are running, by definition you are running multiple things. There should be something for the radio, there should be something for the display and so on. Right? So the operating system should be multi-programming even within this constrained environment. You see all these challenges. So it's not easy now to develop an operating. You can think of this as a very hard problem. It's as much hard as developing an operating system for a computer. Right? With all these new things. So there's not. So the complexity doesn't end there. On top of that, it's a communication tool, right? And it has. Your computer doesn't come with a GSM modem. So your phone has more network interfaces now. There is GSM, somebody has 3G, there is Wi-Fi, there is Bluetooth, there is USB, there is infrared, there is NFC. So you have to handle all these communications. And the more communications you handle, it becomes far more complex for the operating system. So you do all the multimedia communications also these days. You connect to YouTube, you download songs, you play movies, you make phone calls. Your computer doesn't make phone calls. You play MP3s and so on. So as you can see now, it becomes really challenging. And that's why when they designed, so I just talked about Apple started with iPad but released the iPhone first. because they saw that this is a very big market, and if they could combine all of this and nobody else could, then they will have better chance of selling these devices. So anybody knows what you would do as just a problem. You can think about it for 5 minutes. What you could do to make your current operating system run on these new constraints. So if I have a version of Linux, let's say Debian or Ubuntu or something, right, and I want to run it on a phone, what changes I should make? So instead of developing a new operating system, now the problem is just take the existing operating system and try to put it on the phone. What things you think would be necessary to make those changes? Think about it. It's not an easy problem. At least think about it for 2-4 minutes and then let me know. You can form a group among yourself, you can discuss. Tell me what you could do to take the, let's say, even Windows, and then make it run on a small phone. Cloud computing.
Yes. Most of the memory management being done on the clouds and processes being handled on the clouds.
Right, but you still need something on the phone to talk to the cloud.
Yeah, so that's like that is the least hardware you could have to actually run something.
And what happens if you are disconnected?
So can I ask this question? So you're trying to 24 into 7 to your Wi-Fi, and you just burn up your battery.
So just the problem. You heard the problem.
Yeah. So porting the OS to mobile, right?
Yeah.
So what's the point? Why the battery was like made
Priorities changes
Better.
because we have constrained resources on phones. So probably a process which used to take a lot of memory. Priority changes won't be given that much.
So then priority will change. There is something called priority. Very good.
We can start. We can remove all unnecessary services in our
Example.
Example means some services required for like opening a connection and all. That we only running when existing.
So only to start, only those services which are critical. Anything else?
so we can use the multitasking ability of the OS.
Okay. So you cannot completely remove it, but you can reduce multitasking. That's good. And you saw an example. JPM talked about it. So I said I have at the most 10 threads. Can't create anything more, which is limited.
Necessary data can be on the phone and the rest of the data can be on the cloud, like from the same when it connects.
Right, so that is one thing, but right now what we are seeing is in the world, so this as I'm talking about was 1988 and so on, so there was no cloud. If we eliminate cloud from that point of view, then let's assume that there is no cloud yet. Nowadays there is cloud and so on, but even if you assume that there is just no cloud, then what you will do? So I saw three nice things. One is priority, this one, anything else?
Don't load all the programs, just load all necessary programs.
Right.
To save up memory.
Right, so as you were talking about the services. Right.
Basic functionality moving more on hardware and things are getting like this is the core of hardware.
So port some things, we will later on see what some things are, to hardware. Right, so that saves something.
We can reduce the driver set of the
Right, so reduce drivers.
Better process management. better process management.
Better process management. So we have to define what better is. But we can still. So you're giving some nice examples. So this is what exactly, by the way, it's done.
Yes, some of this implemented
Yes.
OS which is for laptop. Because in laptop also there is power consumption.
Power consumption. So some things are, again now what has happened is there is something called an Ultra notebook or just netbook, right, that is coming up. And the Chrome, the browser was designed for these kind of notebooks. So these netbooks or notebooks will not have an operating system of its own. So it will just be a Chrome, a browser based. So these things are coming and it's happening because everything is merging now, right? Phone, tablet and the laptop now are becoming almost like one thing. Okay, so these things are happening. So it's a nice thing. So one thing is priority. Right? In the computing world, we have some priority, but now the priorities will be changed. So one very good example of priority being changed is your phone call. Your phone call, I talk this again and again, is the most important thing. So that has got the highest priority in the operating system. And there is a very standard nomenclature, a word, for these kind of operating systems, where you define priorities. Right? So it's called real time. So if you note this term, real time computers, real time operating system. For example, the missiles, airplanes, helicopters, nuclear power plants, all of these things are very critical things and there are some time or deadlines. So if the pilot switches or changes the direction of wing in an airplane, it should happen immediately. Even in your car, if you press the brake, there should be a guarantee in which time the brake will actually be applied on the tires. Right? So there is a guarantee. And now with the electronics things, there has to be a real-time guarantee. Because how much time does it take when you press the brake and your car stops? Right? So we'll see what real-time operating system is. But your phone is a version of real-time operating system. It's not a very critical like a nuclear power plant or an airplane, but still it should guarantee something. If there is a phone call signal coming in, it should get this signal before anything else. You are playing MP3, you are watching video, whatever is the next thing. First thing is to receive this phone call. So that is what priority is. So what people will do is, when they design this operating system, they will see what all processes are possible and they will assign priorities. Highest priority, middle priority, low priority, very low priority. Okay? And depending on the priority, they will schedule it. So the scheduler that you run on the operating system will not be just a time slice, a round robin method. It will also think and find out what is the priority of this process and will be preempted if there is a lower priority level. Start only those services which are critical. On reduce drivers, it's almost the same thing. So what this means is the Linux takes so much time to boot. If I reboot my Linux, even desktop, it takes so much time. Why do you think it's taking so much time? Right. So Linux, Ubuntu, the way it is defined, the kernel is something which is called monolithic kernel. So it's a monolithic kernel in Linux. What that means is everything goes inside the operating system and the kernel. Right? So even if you are not connecting any USB devices, the USB device driver will get loaded. Right? So everything just gets loaded, so much and so on. Whatever driver you write for your computer get also plugged in inside the kernel. So kernel is becoming big and big and big, and that's why it takes so much time. So if you want to reboot a Linux server, it might even take 5 to 10 minutes. We don't want this thing to happen for the phone. Right? Because when you switch on the phone, first of all, it should not take so much time to boot. And second thing is, we have this limited RAM, 512 megabytes. So we can't fit everything into the RAM. So that's why you have to start only those services which are necessary at that instant. Don't start anything else. Depending upon when the user selects something, just load it at that time. When the user is finished with that task, for example, the USB connection. If the person connects his phone through USB to the computer, load the USB driver. If it disconnects immediate. Reducing number of drivers first of all at the time of booting, and when you are done with it, unload it. This is what Symbian will do for any OS for this platform will do. Reduce multitasking. So in the computer you can have almost as many threads as possible, as many processes as possible. But here in the Symbian OS, you will hard code and limit it. So for example, every application will only have 10 threads. You will limit it. Number of multi-programming also you will limit it. So by limiting all this, you will save on the RAM and also the processing power. Port some things to the hardware. Give me examples of this.
For the reducing the multitasking thing, it would be better if you reduce the amount of RAM you allot to a process. Because
That is also so that's something.
process may utilize the complete RAM, and so the other process won't be able to run. But that's a single process.
Right. So you will not only limit how many you would run as a number of processes, but also every process resource share will also be limited.
Social means that first of all you decide how much application is going to consume, right? Suppose I want to do some task well that consumes a lot more, but seems necessary, but not that work.
So in that case there is a limit. Just like you say, if I want to run 20 threads, but in Java you will not be able to put 20 threads. Right? So every resource will have its own limit, and then you have to write your application by considering those limits.
Yeah, but 10 thread means that I'm going to run about 10 times my calls, right?
Right.
That's too much. But how do you define too much RAM for a process?
So even in otherwise in the standard thing, after all your RAM is limited. I mean whatever you will have on the PC, 4 GB, 2 GB, it's still limited, right? So in that world also there is a limit. That it's just that limit is brought down to a smaller number. Right? So we will of course be finite in terms of memory and processing, and you have to respect the constraint that the device puts. So within 512 you will whatever you can allocate, you will allocate, but then it's still all limited if you want to be fair across processes. So coming to the porting of something to the hardware, that makes it very fast. You don't need to allocate it on the processor. So anybody knows what DMA is? DMA? Or direct memory access. So what happens with DMA is the processor, the CPU, there is RAM. Okay. So in the traditional world, or the simplest thing, the naive approach, is all the communication between CPU and memory is like this. You get the data from the RAM into the CPU, you store it in the register, you do some computation and store it back. Right? So it takes a lot of time. And if you want to then store it to the hard disk, again you get this data like this, and then you store it to the hard disk like this.
Actually, hard disk also is stored from the RAM only, it's not stored from directly.
Right, but somebody has to read this data. The reading part is the engine, the processing thing. Right? You have to send some instructions to read this data, so CPU is involved in it. Because it has to read it. RAM can only store it. But if you have, let's say, something called the DMA chip, what happens with DMA is
CPU bypass करके directly
right.
access the
So CPU is bypassed. You tell that okay, go to this hard disk, look at this sector, collect all the data and store it at this location in the RAM. Right? So all the communication will go like this directly. So CPU is not involved, and you can do something else. So this is one example in the computer where you port something to the hardware. So transfer of data is ported to the DMA chip. So it's also a processor. Similarly, there is something called a GPU, a graphics engine, right? A graphic processor that is taking care of all the graphics. Same thing you would do where on the phone. Any example? What could be done on the phone? So the Wi-Fi, right? So Wi-Fi in the computer world, there could be a software loaded as a Wi-Fi driver that gets loaded into the memory and then it executes the Wi-Fi protocol, 802.11b protocol. So this completely could be ported to a chip, a Wi-Fi chip inside the phone. So it will do all the communication, get all the message, and only when the whole message, the packet is arrived, it will send, okay, get this packet in TCP. So by porting something to the hardware, you will free up the processor, the main processor. So this is one idea. And then better process management, as we talked about. You have less processes, and every process also will have something as a less memory, and then you execute on this. So basically, these are the principles you would use. And it becomes very hard to take the real existing operating system like Windows and apply these patches and create a new one. So people decided, okay, what we'll do is we'll just write it from scratch. So one example is Android. Android was written from the scratch because if we take the existing one and do cuts here and there, it's not efficient, right? So we introduced first concept of real-time systems. So we talked about the priority. The first thing you told me about was priority, and we'll see how it is done. So there are a lot of special purpose computer. For example, even the ATM machine that you interact with for banking, it's a real-time machine. When you put your card, it should within some time ask for the PIN. It should not just wait. If it cannot ask you for the PIN for some reason, it should give you an error message and give you back your card. Right? So everything is real-time in that. So what happens is, if you want to give guarantee of let's say 4 minutes or 4 seconds, so one person puts his card, he should be replied back within 4 seconds. So what you would do now? How would you design that operating system? To give back a result within 4 seconds or within some time. There is timeout, but even before timeout we have. So timeout is something in the worst case. Right? If something doesn't happen, you do timeout. But timeout is not the general case, the average case. So what is that you would need to do?
Giving the highest priority to the particular task and allocating the processor so that it can be done immediately.
And giving the priority, even so, how do we give priority? So what you say is, the display takes 1 second. So if I want to write something on the screen, it takes 1 second. And it should always take 1 second, no matter what. If I take in the card, I want to read the magnetic strip of that card. Right? So there is some magnetic data encoded on the card. I should take 1 second to read that, not more than that, at any point. Right? So 1 second for this, 1 second for display, and similarly, if I have to check how much money, cash is there left in me, I should take 1 second. So all these operations come with a time guarantee. Every operation you do. And if you take this example and to my computer, my laptop, it should mean that if I move my mouse, within 1 second it should detect whatever time. So every operation is given some time value. So now when you have all these time values, so let me write it down. So you define time for every operation. How much time it will take? There is one thing.
For very or every?
So for every operation, you see how much time it will take, and also you define something called a deadline. So you say, I should get back to the user when he said, puts his card inside the ATM machine within 4 seconds, so that within 4 seconds is the deadline. So everything also comes with a deadline. And when you know both these things, then you can see whether I can satisfy this deadline or not. Right? So I will see, okay, I should get back to the user within 4 seconds, and these are the 4 operations I need to do. Everyone will take at the most 1 second, so I can fulfill this guarantee. Right? And then I will rearrange the priorities. Okay? So the operation which has the closest deadline or the earliest deadline will get the highest priority. That is also another way of looking at priority.
But time for every operation will depend on the hardware you use.
Right. So what happens when we cannot satisfy deadline? That is when the timeout occurs. Time cannot be fulfilled, then when the timeout occurs.
No, but it may occur a process may finish beforehand, like before the time for every.
Before is fine. So I am saying at the most. So if something finishes before, it's well and good, right? So I have some empty time, idle time.
But you actually, like suppose you give 4 seconds to a time for every process, and the process finishes in 2 seconds, but you wait for 2 seconds extra for that process.
So when the process finishes, in the CPU world, in the computer world, when the process finishes, it goes away. It will not stay idle and sit on the processor. Right? So for example, it's like an engine, it's like a mixer. Let's say you are operating a grinder. If you finish the task, you will walk away, and the operating system will get the hold of processor. So whenever somebody finishes early, it's fine. If something is getting delayed, so if I say display should take 1 second and 1 second is over, operating system will jump in and kick out that process because there is a deadline to achieve. It can't achieve without this. So at that time it will say, okay, the deadline is not being achieved, so I need to throw you out. So what will be the scheduling algorithm if I have priorities? Priority algorithm. So round robin means everybody gets the same time and I come back, right? So round robin means everyone will get fixed amount of time, 10 seconds, and then again the first process. If I have 10 processes, everybody get 10 seconds and I come back to the first. In priority based algorithm, I will see I have to do these many processes, 5 processes. I will ask every process, what is your deadline? Whichever has the earliest deadline will execute it first, and then this way it will follow. But still there is no guarantee that I will fulfill as an operating system deadlines of all the processes. Right? So there is still no guarantee. And with this we get 2 varieties of the systems. One is hard real-time systems and one is the soft real-time systems. So hard real-time means for every process, if it gives me a deadline, I will satisfy the deadline. So if it says I want to finish this task by 12 o'clock in the night, it will be finished by the operating system. If it says 4 o'clock in the morning, it will be finished by 4 o'clock. So every process can give an absolute value about when this deadline is, and the operating system will finish it. So that is called a hard real-time system. Then there is something which is called a soft real-time system. So that means you can now say relative, not absolute. I say I need to finish one process at the earliest, and then process B, and then process C, and then process D. So for every process A, B, C, D, I don't give an absolute value. I just order these processes in terms of their deadlines. A, then B. Just like you say, I will do homework of mobile computing first, and then let's say operating system, and then computer networks, and so on. So you order all of these, and then you will finish everything in that order. So that is called a soft real-time system. So it will always guarantee that if you give an order, the order will be followed. But there is no guarantee that everyone will finish at the absolute time. So if you want to do this, as I was talking about, there are 2 things which are necessary. One thing is the time for every operation. So you have to know how much time every operation is taking. Then only you can start guaranteeing the soft and hard real-time values. And then everybody will give you a deadline or a priority order. So some of the mobile phone functions are real-time. For example, servicing of the phone call. Not everything is real-time. The messages, SMS that is coming, or the phone call that is coming, these are real-time. So they will get very high priority, and the rest of the things will not get a priority. So Symbian OS, when it all started at the earliest, was not a real-time operating system. So it never considered all of these things when the PDA was being developed. But in the later versions of the Symbian, they started moving towards real time, because otherwise it was very hard to give guarantees. In our operating system or the computer, the desktops and the laptops, it's not real time, right? So it can't give you any guarantee. If you press Alt tab and move from one window to another window, it might just take a long amount of time. Right? So it's not real time operating system. From the phone, the current phones that you buy, there is real time operating system encoded. So that makes it very complex. In fact, more complex than even the laptop, because it doesn't give you any guarantee, but this gives you guarantee. So the takeaway from this slide is, first of all, you should know what a real-time operating system is, and then you should know what the hard real-time system is, what the soft real-time system is, and what is the difference between these two. And the phone has to be a real-time operating system, because there are some functions which are very important and has to be done in some given amount of time. Okay. Also, you should know what the system call is. Anybody can tell me what system call is now at the end? Direct. So within the operating system, define an interface for itself, and which are all the calls. So depending, if you change operating system A to B, the system's call will change. So to make it portable, more portable across the different platforms, There again, Windows 32 APIs and all the APIs, OS APIs, which are built on top of the system calls. So with that, so this is how you communicate. You make an API call, that API call will land inside the system call and it will be there. Right? And these are the things you would find when you move from a desktop or a server operating system to a mobile operating system. One thing is the priorities change. Second thing is you start only those services which are necessary, unlike in Linux where you switch on everything at the beginning. You reduce multitasking, so you don't start too many things at the same time, and we'll see what are the core things. In fact, we have seen in the operating system cars. One example, so I talked about monolithic operating system. There is another operating system which just starts the core thing. Anybody remembers the name? Microkernel. Right? So there is something called the microkernel, which is a very popular term. And even the desktop, the laptops at least are using this idea, microkernel. So in the Symbian world, it's called a nanokernel. So we'll see what a nanokernel is in Symbian and how is it different from other kernels. Then port something to the hardware, which is a very simple thing to do, so that the processor is not taxed to do a lot of things. So some things you typically do again and again, like GSM. Wi-Fi communication, USB communication, you just move it to a separate processor so that your main processor is not taxed. You reuse the drivers that you load at the boot time, and when you are finished with using the drivers, unload those drivers. And then the better process management. If I take an example in Linux, and Linux access everything through a file. We talked about this. So if I want to talk to the mouse, or to the even display, I will talk through a file. One example of this, if you are connecting to a serial port to a printer, you would use something called /dave/ttya and so on. Even for USB, you get a file. So everything is through file. So that is how Unix is built, and that defines the character of an OS. So if you create a new device driver for Linux operating systems, and you have a new device connected to this, you also would be implementing it as a file. Then only you are in principle with the Linux philosophy. Right? Otherwise you will move away from it. Then Windows also uses nomenclature of files to address resources, but access to them is through unique APIs and not through file IO operations. So in Linux, everything through read and write. So for example, the std in and std out that you do, or printf and scanf, even that goes to a file, right? No matter whether you are using the display or the real file, right? So that way everything is becoming very simple. In Symbian OS, we use something called a server, client-server model. So there is a client running, which is maybe your application, and the server is something that you would use to write to a file, even to a file operation, right? So when you write to file, you will call that server to communicate to it. For example, if there is an NTFS file system implemented on your phone, there will be an NTFS server. If you want to communicate through Wi-Fi, again there is a Wi-Fi server running on it, and everything is through server. So all the code that you would see is through a server interface. Right? And this is what the engine approach is. Right? So this is a separate engine. So three kernels that we talked about different is a monolithic kernel. So for example, a Linux. So everything is inside the kernel. The kernel becomes. Anybody has compiled the kernel for Linux here? So you have done. Right? So it takes this long time. Right? If you recompile the kernel again, it goes through a long process. It takes huge time because it's one single object, one kernel. There is another approach which was talked about in the OS is microkernel. Where what you do is you just strip down lots of things from the kernel and just reduce it down to the very basic thing, like processes, memory and method, that's it. Everything else is outside the kernel. Right? So Symbian OS also is sitting outside the kernel. Okay? So communication will happen like this. The software will talk to the server and server will talk to the kernel and so on. So the advantage of this is if I change my kernel but still keep this interface constant, then I can use the same user software. I don't need to change it. Okay? So servers are independent. Also, when I start my phone, switch on my phone, I just need to start the kernel. Depending upon when the user software gives me an API call, I can start one server, necessary server, and I can switch off that server if it's not required. So by using this concept, the phone is more responsive and also it can run on a very smaller memory footprint. So let's stop here. Again, to remind you, your project proposals are due on Tuesday now. And those of you who haven't talked to me can come and talk to me now. I'm in the office.